Okay, sir. First of all, I'll introduce.
Sure.
Hello, everyone. First of all, I welcome you all of you to today's Tech Talk. Today we are with Sai Boothkuri, one of our have different domain, right? Many of us don't know what is mean by VLSI also because it is fancy. That's why we are choosing VLSI as our goal. So today we will have a session with Mr. Sai Boothkuri so that we will solve all our doubts. Today I am act as your mediator. I will reach all of your doubts and questions to him. Thank you. Sir, can you start your presentation, sir?
Sure. And yeah, first of all, right. So very thanks for inviting me to this Tech Talk. I would like to thank Rafi sir
Hello,
and
sir.
the fraternity here. You can hear me, right? Hello. You can hear me, right? Hello. Yeah. Are you able to hear me? Okay. Let me know if you are able to hear me or not.
Yeah, I can hear you right now.
Okay. Okay. So yeah. We can start, right? So okay, so let me start. I think you are able to hear me, and no logistical things are there right now. Okay, so let me start. Let me start introducing. Start introducing me. So I'm Sai Boothkuri. So I have been a student of the RGKT RK Valley from R11 batch, and I have graduated there with a gold medal from Electronics and Communication Engineering. And post the same, right? So I during my third year of the during my final year of the BTech, I have been selected as an intern at Intel. And since then I have been working there itself. It's been around 8 years, approximately 8 years that I have been with Intel overall actually. So throughout my career, right, so I'll share how my journey started from the internship, and what all made me the motivation that I had, and the my initial pre-silicon days, and my exposure to the post-silicon. And yeah, I'll also talk about the innovations that I have done so far there, and I hope that would help you in at least guidelining your process and your career, maybe in most of the VLSI projects. And post that, I will be talking about the various trends, I mean various opportunities, the job opportunities that are available in the VLSI industry, specifically on the pre-silicon side and also on the post-silicon side. And I may be touching the manufacturing side a little bit, but not extensively. And we'll talk about the the hierarchy in various organizations. And
Sir,
we'll also
I think your connectivity is slow, sir.
sorry.
Some buffering is happening, sir. Okay, sir. Now, okay, sir. In between,
No.
there is some buffering, sir.
Okay, sure.
Okay, sir. Now, okay, sir.
Yeah, okay. So yeah, so my internship, right? So I started internship at CPU verification in the pre-silicon domain during my final year of BTech, that is 2016. And then I have worked on various programming cases there, and the validation of the CPU scenario specifically for the rare events. And then I have been hired by Intel, and from there I started my journey with validation of mostly my all the experiences in the verification domain. That includes pre-silicon and post-silicon. Started my journey with the MLC validation. MLC is mid-level cache validation. I have been the global owner in the protocols in the IDI protocol, and also I have been with the. There have been multiple
Sir,
global ownership. Look,
sir, your audio is not clear, sir.
is it? Okay.
Um,
Mm,
sir.
how about now? It should be better.
Okay, sir. I mean, in between, there is buffering, I think, sir. Okay, sir. Now, clear, sir.
Is it fine now? Uh,
Fine, sir. Sorry for interruption.
I think you can hear me well. I'll proceed. So yeah, so I started my internship. Uh, uh, so starting with the verification on the CPU side, and then I started my career after hiring from the Intel, right, on the mid-level cache, and then I also a part of the out-of-order validation team, and then for a brief period of time I have been in the post-silicon validation team at CPU verification. And then I came back to pre-silicon for the power management and the peripheral validation team actually. So that's very 8 years of career throughout my career at Intel actually. So Yeah. So throughout my journey, right? So I have validated on the out of order validation, on the cycle level retirement. I validated on the cache, all the cache protocols, and on the coherency, consistency part of the data. And I have validated on the post silicon part of the CPU as well. So it's completely a black box validation. I will talk about what are those scenarios and how are various skills involved there and what would you get out of it. Yeah. And as part of innovations and presentations, right? So there is a novel AI based performance validation that we have done, and that was being utilized and got deployed in various projects at Intel. And that paper I have presented in VLSI forum in 2023 at Hyderabad actually. So yeah, that's all my journey at Intel. And yeah, let me move ahead in various slides that I want to talk about. So yeah, before even understanding various cases, right? So let's first try to understand the ASIC design flow. So first, it's mostly from the understanding the requirements of the customers, and then understanding how exactly those requirements can be fit into the product level information. That will eventually turn into the architecture spec actually. So typically an architect will define the architecture and the specification of a particular product, and this particular product will then kick off into the design phase basically. And this will be started by the design as well as the pre-silicon verification, which go hand in hand, along with once the design and the functional part of the design is ready, without without any bugs, right? So by completely validating all the functional cases, it will be some in some projects it will be sometimes in parallel and doing the logic synthesis and the netlist generation, and there will be equivalence check, and in the back end there will be a placement and routing in order to get the efficiency out of it. So this is a second stage, even though I have shortened it a lot to make sure that you understand it. But there are a lot of stages involved. There will be a lot of human hours, and there will be a lot of engineers working on the same project on multiple things in parallel actually. So this requires the front end and the back end people working in and fro. I will talk about what exactly is front end and what exactly is back end, and where exactly the various engineers involved in doing the projects, right? Yeah, once you see all the pre-silicon things are done and you see that it meets the timing criteria and it meets the power and performance numbers indicated by the project as per the spec, and there are no bugs involved, right? So once you get the confidence on the product, you will deploy it for the silicon. And once there is a silicon available, so not all the companies have in-house silicon. There are companies that give the silicon to other manufacturing companies like TSMC. So once the silicon is available, they go ahead with the post-silicon validation. And this post-silicon validation typically requires all the features to be enabled and maintain that there are no bugs involved over there. So it's typically a complete right from the spec, right from collecting the requirements from the customers, identifying the required features required to it, and then put it into an arc spec, and then doing a design and verification in parallel along with the backend logic synthesis, netlist creation, the GLS, and the placement routing and the backend build things, right? And then once you see that there are no bugs involved even in the post silicon, then you go ahead and release it to the in the market basically. So we call so that is when you tell a project is basically a taped in basically, or it's PRQ'd basically. It's so that's a typical ASIC flow, ASIC design flow that is available. Okay, that you can understand it in that way. So if we move ahead, right? So there are in the design ASIC flow, once you understand it, so we can understand what are the different job roles that are available in the industry. So as I said, so there are specifically I have categorized into pre-silicon, post-silicon for the better understanding. So in the pre-silicon there is front end and the back end. So in the front end and the design side, so we have digital design, right? So we call RTL digital design engineer, and the cases where we have analog for the analog related design, we have analog design engineers. And then comes the verification, which I come into the picture, right? So there are multiple verification agents involved. Mostly it's the few of the companies go ahead with the IP verification engineer role, and for the analog designs we have analog verification, and where there is a mix and match of both for the sensor level informations, right, or sensor level IP involved in a typical project. We have AMS, we call analog mixed signal verification, and there will be engineers involved there as well. And for the to make sure that the project is defect free, we have DFT, design for test, and for all the integrations of various IPs, right? So we have SOC or system level verification also available. So there is a different set of engineers involved there to make sure that all the parts are integrated properly, and no miscommunication happens, and all the designs are in sync with each other, such that the communication between one IP to the other IP happens in a better way. And we have gate level simulation. Gate level simulation will be helping us in fixing all the timing related things, like the setup time, the hold time, and they do not ensure we miss that we do not miss any timing criteria, right? We have gate level simulation, and people various engineers also involved. Then there is a different type of verification nowadays. It's becoming more of a trend that each of the company is involved there, and we call it a formal verification. So we have formal tools. We use heavily the SVA, system verilog assertions, and it can be used both as assume as well as assert, to make sure that instead of writing the stimuli, we allow the stimuli to be generated only from the tool, and tool will give us the failures if we have in the design. So that's more from the verification side. And in order to evaluate the power and performance of the system, right, or of the IP, nowadays we are having power and performance evaluation engineers, and for all the various metrics that are available, right? So we have CAD tools like generating the net list, or generating the placement routing of all the blocks that are there in the IP. And coverage related metrics, we have various tools, and like viewing of the coverage and launching the regulations, observing those regression results, whether there are failures or not. So for those we have CAD tools, and pretty much that there are integrators also to make sure that all the design changes and the verification changes that go through the pipe in a sync way, such that no changes are missed, and no changes are being left out. So there are integrators also available in the front end, and in the back end, right, we have physical design engineers, which work on wide range of spectrum. There are various IPs that they work on RF, and they work on timing fixes, they work on routing, placement, and all the various scenarios actually. And then comes the post silicon. So post silicon, we have post silicon verification, which makes sure that functionally we do not miss out any bugs, and all the project criteria are being met as per the architecture spec. And then like we have the performance in the pre-silicon, right? And we also make sure the numbers that we are viewing in the pre-silicon should also be maintained at the post-silicon as well. So we have performance evaluation team sitting on the post-silicon also, which gives us the actual numbers, such that any feature that is being introduced upon the customer request, right, is working intendedly in the same way or not. So these are the various job roles that are available for us in the VLSI industry that we can explore, and we need to choose in where exactly we can fit in, and then take our career accordingly. Okay, with that, let me move on to the next slide. So with the things that are available, right? So with the various roles that are available, how exactly that you grow once you enter into a industry, right? So you when any engineer for that matter, or once we have completed our BTech, or after completion of the internship in various organizations, right? Once we enter into a typical VLSI company, you will start basically with an engineer So irrespective like the jobs that we talked about so far, right? So specifically in my case, I started as a silicon verification engineer. So and then after gaining expertise over a domain, we will move to a senior verification engineer. And then once you get a command on all the related things, and once the organization gets the confidence on you, so and you will be given responsibility with an additional number of folks. There you will be leading a team, we call that as staff engineer. After staff engineer, so now the domain will increase, and you will increase your expertise into multiple domains, and now your area of ownership also increases along with the number of people that you will be working and the product that you will be leading, right? So then you are going to get a senior staff engineer. And then with the increased scope, with the innovations that you bring in, with the goodness that you bring onto the platform, right? For the particular product IP, you then you will be promoted to a principal engineer. And yes, and here comes like in some organizations there can be architects, in some organizations it's called distinguished engineer, which is upon the promotion of the principal, where you define, you sit with the customers, understand their requirements, and then you formulate in terms of design requirements, and then and you start products, right? And architecting those products, that's the architect and distinguished engineer. And then on promoting towards it, right? So we have a senior architect and the senior distinguished engineer. And once you get a whole idea, I mean, once you get the in and out things and everything that is happening in the IP at various projects level, and you have worked it on multiple projects level, so then Intel with the sitting of the VPs and various senior management, they will decide that to get into a fellow. And then the senior fellow is one of we will have any handful of people inside a company basically. So they fellows and senior fellows, right? So they have typical patents available to them. They might have innovated a lot. They might have brought a lot of innovation, and they might have improved a lot of performance and significance of the product in the market. And yeah, so based on all the achievements that you gain so far in the technical ladder that you see here, senior fellow is a greatest technical thing that you can achieve once you enter into the industry, and gaining all the expertise, and giving everything that you can for the product to be more and more better actually. So yeah, so this I mainly added to make sure that, right? So what exactly what hierarchy that I need to aspire for any graduate that is entering as an RCG, recent college graduate, to the company. So they have to have this in mind to make sure that how exactly they want to grow, how typically that they want to involve in all the project cycles, and with this keeping in mind, and how to interact with the people over there, right? So you will get a broad idea, and how to the respect and the treatment that you need to inculcate, and make sure that you need to understand their broader picture, and work accordingly once you enter into the industry actually. So this is one, it's purely technical in nature, and there is another ladder, what we call is a dual ladder. So like we talked about, right? So like the engineer, senior engineer, and staff, senior staff. So there is a curve that you can observe, that from the engineer 3, so there are two things that you can that basically gets diverged. Whether you want to go into a staff, technical path, then you go ahead with the staff engineer and all, or you want to go managerially, that you want to manage stuff, then you want to give if you are a people person, then you want to deliver good thing, deliver good in terms of helping people, or making sure that people get the right traction, right resources, right technical strength, right? Yeah, so all the those are basically the managerial stuff that you can take the road towards the managerial side. So we start with by first level manager, and then second level manager, then you can reach up to a director of engineering, where you all the project is being handled, and then you will get a product manager as well. And upon promoting from the product manager, you can be a director of the engineering for a particular group, and or particular product in entirety. and then you can become the VP of the engineering, and then CTO, and all the high level things basically. So even CFO, CTO, and CEO, and all actually. So that basically is a managerial track, and the other we discussed prior to it, right, is basically the technical track. That's available, or that you can have a brief idea with. Okay. With that, let me move to the next slide. So yeah, so far we have discussed on what are all the roles that are available, and how once you enter into the industry, how you can view yourself, or where exactly you are in the technical ladder, or where exactly you fit in your product, right? So, but let us try to understand what are the major VLSI companies that people know of, and what are their products actually in the market, such that you will get a brief idea on where exactly that you can go in. With this in mind, right? So keep what are the products, and what exactly are there, what are the companies that are available, right? So keep that in mind, such that we will discuss in the courses that are required to it, so that you can enter the proper you can map your learnings to a proper industry that you can go in, or that you are best fit in basically. So CPU core, CPU. If you learn the computer architecture, we have it in ECE, also in CSE, I guess, and EEE in most of the colleges. So CPU cores, which basically once you understand the computer architecture, CPU core is the typical place that that will help you in landing your job there. If you look at the CPU cores here, so there are three types of architecture. The x86 architecture is the typical CISC, or complex instruction set architecture, that is available, right? So it's with a multiple instructions and variable decoding, and a lot of instruction set that is available, and they can be complex as possible. So that we have Intel, and you might already be knowing, right? So we call i3, i5, i7 systems that typically we use in our laptops. And Intel has been recently codenamed to Ultra as well, right? So that one such company is Intel, and I happen to be part of the same CPU core. And I have been with the I have worked on various generations starting from 11, 12, 13 actually. And we have AMD in the same category, and AMD basically, if you can take an example, right, it's all the Ryzen products are typically CPU cores basically. Yeah. There is RISC. ARM-based architecture is called as the RISC architecture, where you even though architecture is reduced instruction set, but ARM is typically widely used in major of the IPs that are available. There are CPUs using the ARM architecture also, like Apple uses the ARM inside it, and it built its CPU on top of it, right? So, and there is in the recent trends, right, you see RISC-V. RISC-V is a reduced in the same way, but it's more like an open source architecture that is available these days. Even though architecture is open, but I believe design is not yet open. Example for such company is Sci-Fi is working on the RISC-V. So I have an example there. And like any mobile devices, right? Any mobile device that needs to work, it needs to have a motherboard with it, and it needs to have a chip inside it. And when it comes to mobile, people immediately get, right. So we have Apple, we have Samsung, we have Qualcomm, and with the Pixel phones, right, we have Google. So all the mobile computing, all the mobile related, so there are mobile chips inside them. Which interfaces with all the sensors, the camera, the peripherals like the volume buttons and the power button. So all this taken into picture, and the architecture is accordingly in the mobile segment. And we have servers, so all the cloud companies, all or major server related things, right? So we have major companies here, like the Intel and the AMD are two major server companies that are there. And even though we have IBM is mostly constrained towards the bank servers actually. And so typically for any system to work, right, we need DRAMs. DRAM is a typically memory segment. So we have Micron, we have Samsung, we have SK Hynix, various companies which are working on DRAM. They not only develop, but they also manufacture the same DRAM chips as well. Now with the AI wave, right? So we call that as a fifth industrial revolution. And yeah, with the AI wave, there is a much and much needed for the architecture, the GPUs that are coming into the market. And we have ML accelerators. Also, people, companies started building their own accelerators also. So we have, when it comes to AI, right? So for one thing, one company that comes to mind is always NVIDIA. How big it has grown in the recent market with the GPUs that it has provided, even though, with the various segments that are there. And it's one of the product leader that we see from the AI wave point of view. And AMD is also there, and AMC also recently is taking some market over there. And recently Google with the TPU flows, and Microsoft with this AI SoC also entered into the AI segment. And so with that things, right? So there are IP designs also which works on sensors, which works on like a fingerprint or any with the Thunderbolt connectivity, the USB connectivity, right? These typically gets integrated to the motherboard. And there are the companies which are mainly responsible in design. So we have NXP, we have Analog Devices, we have Broadcom, we have MIPS. Basically we work on individual IP designs actually. So like we discussed in the other slide, right? So we need various tools. So in order to make sure that the product is bug free, and make sure that the product is running smoother by having various metrics that you can quantify, right? So we have EDA vendors available to that, and we have dedicated companies like Cadence, Synopsys, Siemens, and Ansys, which make sure that you have all the design visible to you. I mean, you can physically view the design, you can physically view the routing of the each transistors level information and the netlist information, right? So in order to view them, we obviously need the engineering design automation tools. So for this we have these companies. So yeah, these are the major companies that are mine, but there are a lot of startups. Obviously these are the product based companies, but there are a lot of service based companies also that make sure that you end up reaching to the either of the product company, where you take in a specific product specification into mind, and you do current job, and then you move on to the different product companies. So we have service based companies like that as well. Okay. So yeah, with that keeping in mind, right? So where exactly the VLSI industry is trending these days, right? So now 3 nanometer is what there are TSMC is working on. And there are a lot of advancement in the semiconductor industries, specifically in the manufacturing sector, right? So such that there is advanced lithography, and that helps us make sure that we have high yield. That means when you manufacture it, you make sure that there are a lot of maximum number of chips can be extracted from a single substrate, right? So there are a lot of advancements happening from the manufacturing side. And there is heavy innovation going towards the 2 nanometer. I hope you understand the width, right, between the two components. Basically is the node size that is available. So now it's trending. TSMC has recently worked on 3 nanometer. Now the industry is trending towards 2 nanometer, and not sure how exactly it will be trending to. And there can be beyond 2 nanometer also that people are speculating. In terms of wireless communication, right? So every mobile device we started with 2G, 3G, 4G. Now Qualcomm has revolutionized the 5G in the mobile segments, and there is a heavy innovation also going from the 5G and beyond in the wireless trends. And we all already witnessing the AI wave, right? So the AI wave where we have the high demand of the GPUs for the lot of trainings and lot of inference that so typically requires the GPU for the and the accelerators. And using this AI and in the integration into the VLSI, right? So now we have ChatGPT available. Similarly, a lot of companies are working in the in-house tools to make sure that everyone has their own version of ChatGPT. And and they use people are companies are also even encouraging to use their version of ChatGPTs with them, to make sure that people get much more efficient code, or to take the help of those LLMs, and make sure that they improve the efficiency that they improve the proficiency of the code that they are going to put in into the designs actually. So yeah, the obviously the AI way, and yeah, and the improved security, right? So a lot of companies now, it's not only functional mode that's typically required now security is also one of the big things that every company is invested in, because now the data has become more and more innate in nature, and this data will obviously make sense that you don't want to put it into a different person unknowingly or knowingly. So make sure that data, whatever people have are are provided with, they have to make sure that there is no breach of data, irrespective of anything within the provided spec actually. So there is a lot of innovations going on from the security point of view. The companies are now having a standalone security teams as well, to make sure that no security leaks are being done at any point once the product is released actually. And yeah, now we have autonomous vehicles also, like Tesla and even Ola, right? So with those, right, so you do not want to waste even single miscalculation that can eventually lead to accidents, right? So there are various standards that are coming up. For example, the FUSA safety standards, we call FUSA functional safety. So those level standards, the coming up of a standard level architecture over there, and making sure that whatever the autonomous vehicles, or for that matter any automobile sector, right, if any chips that go into those signals, they into go those segment, right, it should make sure that it's FUSA compatible, and make sure that it's defect free, and it ensures all the safety required for the passenger, to make sure that there is nothing went wrong, and because it obviously costs the human lives at the end of the day. And people now heavily are looking towards not only a pure software based code, or pure hardware based code, right? The co-design between software and hardware, and bring the goodness of the hardware, as well as bring the goodness in the software. So the co-design for a good return in the performance is also a high trend these days. And with the RISC-V, with the RISC and the x86, the complex architectures, and with the increase in the IoT demand, right, where you don't need a heavy CPUs, you just need a small CPU with a reduced instruction, such that it can make sure that any IoT communication happens to and fro, and it also can handle a little bit of computation inside. So we have RISC-V, and now the RISC-V architecture is now being more towards the open source, and such that everyone is viable to the architecture, and make sure that they can design their own chips. So RISC-V open source architecture is also for the customer, for the customized ASIC, is being highly trending these days actually. Okay, so yeah, those are the industry trends, and how exactly you can enter into the how exactly you can enter into, right? So I have listed down all the important subjects that you can look at. So you obviously need the digital electronics knowledge, which requires the number system, combination circuit. We call STLD in our college, I guess. But the digital electronics, which is nothing but the STLD, switching circuits and logic design, which indicates the same actually. So the number system, the combinational circuits, the sequential circuits, and the memories, right? So, and I listed down the various books that and the websites that we can follow. So those are very heart and soul of the VLSI basically, and you need to understand them at very depth, and have as good as hands-on as possible for those as good as theory also available to them. So in order to design these systems, right, that you learn in the digital electronics, you need to have a design coding. So we have VHDL for that, as well as the Verilog. Verilog is now heavily used across the industry, but VHDL is also being preferred in some of the companies. You need to have scripting, making sure that you automate the various cycles. That you don't want to miss in the human cycles, right? So you make sure that you understand that you get a hands-on scripting knowledge also, using various languages like Perl and Python. such that you can once you understand the inefficiency in the system or inefficiency in various doing the execution work, right? You can bring in the automation there by using the scripting languages here. People heavily use in the industry, and it will be a very good value addition to your resume. We have basic electronics. From the basic electronics, right, you need to have understand all the network theorems like this, all the network theorems, and you need to have good understanding of the MOSFET, filter circuits, DSP concepts like FIR and IIR filters, and understand the semiconductor physics, like what is the gate level width, and where is the substrate, and how exactly the gate level mean, and how it impacts the power and performance, and the frequency is impacted by the by those semiconductor level information, right? So that you need to have a very good understanding in order to enter into the analog industry, specifically while the analog verification or analog design parts, right? So with the microprocessor and microcontroller knowledge, right, you can enter into the CPU industry with the x86 or RISC-V or Intel, AMD CPU. Now it is NVIDIA, right? So with the microprocessor and microcontroller, you can implement. You can refer to the books that I suggested here, right? So yeah. And we have analog electronics also, like the amplifiers, oscillators, feedback amplifiers, specifically helpful in the designing of the sensors, right? So, and the diode circuits, function generators, and all the topics that are critical when you want to enter into the analog industry. You can follow the digital integrated circuits by Rabbe book. It's one of the best book that is available. And you have to have the idea of the static timing analysis, like the setup time, hold time, and the metastability concepts, and the whole slack calculations, clock skew, and all the clock related, like the slew and the propagation delay concepts, right? In order to make sure that you have a good the GLS understanding as well as the backend related activities as well. So yeah, that's all I have planned for all the slides. Yeah, let me know if you have any questions, and feel free to ping me. Let me know if you have any questions. Actually, with that, I have completed my slides, and yeah, I'm open for questions now.
Video Hello, sir.
Yes.
Yes, sir. Thank you for your valuable information, sir.
Yeah, thanks.
Even me, as an VLSI aspirant, I have got many information from you. So many people from our college want to know some of the things from you, sir. There are many questions from people, so I am here to reach out their questions to you, sir.
Sure.
Can we have a Q&A session, sir?
Sure. Please go ahead. Yeah.
Okay, sir. First question is it better to write GATE and do MTech from top IITs or go to placement after BTech, sir? Which is more preferable according to you?
According to me, right? So I personally, I have never went to GATE or MTech, right? I joined BTech. From the BTech, I have been hired by Intel actually, but there is an added advantage. With 2 years in the industry, right, you will always exactly reach to the same point. But if you have the capability of doing the research work and understanding the things in a better perspective, right, so you can go ahead and do the MTech as well. But yeah, definitely MTech will be an added addition in your resume. And it's and if you can't afford it, or if you can't have if you want to enter into the industry immediately, you can make sure that you get 2 to 3 years of great experience once you enter into the industry. And you can leverage both of them in parallel actually. So it's not MTech. Nowadays industry started hiring from the BTechs also. But if you want to go to a big like the performance evaluation team or the AMS verification team, right? So there are some big profile areas that are there that specifically look for the MTech candidates. Even for that matter, the research areas in the VLSI, right? So where the labs will hire you to make sure that they do the proper research content rather than the execution content. When I say execution, that you will be working on a project. When I say research, that you will give the information required for the project to go ahead with it execution actually. So those kind of research things, MTech will be definitely a value addition. But if you want pure execution, right, without MTech also, that you can enter into the industry.
Okay. So how is the workload and work-life balanced as VLSI engineer as compared to government jobs?
VLSI, yeah, it again depends on your sector also, right? So work-life balance will be good. I mean, you will obviously, I mean, even the people nowadays are now getting aware. So far, right, VLSI is clouded under a big stream of software engineering, but nowadays that cloud is being disappeared, and now you are getting identify yourself as a hardware engineer, right? Yeah, now with this, right, so the work-life balance will be yeah, I mean, it's very good, at least from my side. If you, I mean, from the Intel point of view, even if you ask our alumni also, work-life balance will be very good. But when compared to the government job, right, yeah, you can see that it's one of the same actually. I don't see any difference from the government job, except from there is respect that you get in IAS and IPS, right? So apart from that, you will see the same benefits. Pay will be huge, right? It's incredible pay in VLSA industry when you compare it with the government jobs, and work-life balance will also be accordingly. It's great. At least you will feel somewhat pressurized, or you will feel sometimes, but it's during the end of the project cycle. And but it's not 24/7 or 12 months a year actually. It's for a brief period of time, but once you manage it efficiently, right from the beginning, you will not even feel that as well. So personally, if I personally, it's the work life balance is really good when compared to the but I mean, when compared to the pay, industry is really good. Real estate industry is really good actually. Yeah. I hope that I answered your question. Okay. Yeah. I have the question here. So how manufacturing or design flow for GPUs is different from CPUs, right? Yeah. CPUs and GPUs are different in its architecture. CPUs are more in terms of various workloads, irrespective of any workload that is available to you, right? So if you want to run an application, any application can be run on CPUs, but GPUs are mostly the compute intensive actually. That means if you want to run more and more vector related operations, if you typically look at any gaming industry or AI workload, when you are trying to make sure that you are running an algorithm, right? It's the vector operations, right? So you multiply and then add, and you take out a vector there, and then you multiply and add, you take out the values there. So the GPUs are mostly compute intensive, and CPUs are more towards more broader, more broader architecture, where you can do the compute, and also you can do various level applications also, like so you can run various applications on CPUs, but not the same case with GPUs. Are mostly used for the intense compute kind of applications actually. And yeah, CPUs are not they can have hand in hand, and GPUs will make sure that your content is run much faster, but you obviously need CPUs as well to in order to get the workload being executed properly by the OS as well. So if you understand the basic funda here, right? So then architecture will differ a lot. Architecturally, there are a lot of differences as well from the GPUs and CPUs. And manufacturers is accordingly falling in line with the architecture actually. So yeah, majorly is the compute intensive things, and mostly it's the reduced instruction set in the GPUs, and mostly it's for the vector related operations. You can't have a nuke, or you can't have multiple epic related activities, right? As high as CPUs. So your architecture will differ in terms of CPUs and GPUs. Yeah, so there's another question. Your opinion on NPUs and TPUs introduced in mobile phones. Recent iPhone 16 release has become the first generation of introducing AI at the mobile level, right? So, yeah, obviously, right? So, NPUs like the neural processing units, and TPU tensor flow units, right? So, tensor flow processing units. So, basically, right? So, irrespective of anything, right? Once you have added architecture, or once you have added hardware on the mobile segment, right? So that means your computation is now at a significant higher level actually. So previously we used to have handle the computation only by CPU. Now we have added two more agents there, NPUs and the TPUs, which will make sure that all the computing intents, like for example, right, mostly right in mobile phones you use cameras, and for cameras you need processing, the image processing, and you want to add various technologies various technologies involved there that can make your phone look as good as possible, and your camera is as efficient as possible. So rather than have this heavy workload, right, like all the compute related operations there, rather than have CPU work on it, we have NPUs and CPUs, which will basically reduce, right, or it will be as fast the mobile phone can be. So introduction of NPUs and TPUs are revolutionizing the mobile segment these days, and adding them basically will make the workload work as smooth as possible with as heavy computation that we can do. And yeah, you have infinite possibilities that you can do in terms of software, right? Yeah, and it's also one of the great things that are there. And also there are advantages, right? So NPUs and TPUs will be adding more cost onto the silicon, but yeah, irrespective of that, the people are using applications coming out of NPUs and TPUs heavily. We can observe them on the cameras that are readily we can see, and we can also observe them on the gaming, right? So now you can play games at even at 30 fps, or 15 fps, 10 fps actually. So that is all with the goodness of NPUs and TPUs bringing onto the onto the mobile phone platform. So yeah, that's the case. So gaming is much faster, and camera is more effective, and you can have as much beauty as possible. All the network related things can be get at a more speed. So yeah, everything is fast. So thanks to NPUs and TPUs, right, they makes the phone much faster, and every generation to generation. So yeah, do you have any other questions? Yes, yes, obviously, yeah. So can CSC people enter into Intel, and what are the major qualifications, right? Yes, obviously, CSC can, computer science people can also enter into Intel. In fact, people are being hired from CSC background as well for various internship programs, right? And the major qualifications, right? You should be very good at programming, specifically like from the C level actually. So you should be very good at programming. You should have computer architecture knowledge as an add-on, and yeah, as good programmer that you can be, right? Such that you can help build the EDA tools more efficient, and you can exercise more excessive content with various complexity involved, right? So if you look, if for example, right, if you take uh, um, uh, what do you call the instruction generator, right? So RITs we call random instruction generator, right? So those are typically being developed by the software people itself, and that typically required heavy programming knowledge. And some of the, if you had a computer architecture knowledge, that would be very good add-on. And yeah, so yes, there is a lot of scope for the CS people at Intel as well. Yeah, and yeah, I mean, even Intel is hiring the CSE people from our college as well, right? And they are being, in the performance team. They have been in, the software team as well. Yes, yes, yeah. Make sure that you have good programming. Make sure that you have good C language, and make sure that you have good computer architecture knowledge, and yeah, and have your basics been like the DOA, right? Algorithms also have good command on them. Yeah, make sure that, I mean, Intel can give you an opportunity in that front for the internship opportunity at least. Uh, so I did not have. Okay. So I have a question here. So does CGPA is more important to enter into Intel? Yeah, but not as important actually. But CGPA is a one criteria that helps you stand out. But if you have good projects, right? So it's not a alone criteria, right? CGPA can help you stand out, but if you do not have CGPA, right, you have you can work on various projects, and if you can showcase your projects during internships, right, or your or even your selection criteria, that would also help you basically land into Intel actually. CGPA is one of the important criteria, yes, but it's not alone. It's not a alone criteria for the selection. I see from what's your perspective on VLSI, into VLSI track? No, I do not. Yeah, could you rephrase that question? I think I do not have an idea on the fastest silicon from the Cerebrus company. Maybe yeah, I'll try to get an idea. Maybe I can comment on it post that. But at the end of the day, right? So with the Moore law, with the number of transistors increasing exponentially, right? So you can observe as many transistors that are there, and you can expect, there are various problem statements also coming to it, but the industry is very technically good enough, and the problem statements also getting answered accordingly, right? So yeah, innovations are being brought in to make sure that we get more and more number of transistors with the with the demand of having more hardware components in the chip, right? So yeah, but on the Cerebrus company, I'm not sure, but yeah, it's a good learning for me as well. Thanks for bringing it up. But I can check and get back to you on that. So, yeah. What is from the RGURD? What are the projects you have done in BTech to get into Intel, right? So, yeah. So Intel was the first. At my time, right? R11 is the first batch that Intel it got hired. So I have worked mostly on robotics, and I had mostly the projects on the robotics itself. So I worked on hopper robot. I worked on bipedal robot. So it's mostly on the and I had the interface of embedded systems there. So yeah, it was mostly on the robotics. It's been 8 years actually. It's the embedded system that I had good command with, such that how can I write a program into the microprocessor, right? I used Arduino boards. I used 8086 boards for the communication with the of various components that I can write code with or play with those components actually. So those projects help me. The projects really helped me. How electronics are going to change the world or affect the future, and how to utilize them, right? So yeah, you can see, right? So the electronics has huge impact in everyone's life. And yeah, without electronics, I think you can't even get up, right, from the from your bed. You have to have your mobile by side, and you have to have mobile before you go to sleep as well, right? So yeah, it's self-explanatory that electronics are the future, and it is trending now, and it will be the future as well. So lot of hardware components getting added with the AI wave, right, and with the GPUs and TPUs, NPUs, and all the ML accelerators that are available these days. You can make sure that you help the system to learn anything with the right set of course, the right set of algorithms and right set of data, of course. You can make sure that your hardware can learn, and it can help you in any way that you can benefit with. So there's a huge capability, and even we have the architecture available now. So it's up to us how you want to invent new, right, or how you want to make sure that you have the hardware component available to you, such that you can make your life much and much easier. So yeah, we can utilize them in any way possible, making sure that you have a right AI algorithm, and you use the right GPUs, and with the right set of CPU workload that can be making sure that to get the better inference, right? So you can I mean, yeah, you have every opportunity available to you, and it's up to you how to utilize them actually. So it can be utilized in any way possible. At least I see it in that way. Yeah, just to put in more perspective, right? Like, there are hardware components not that are now even cleaning, right? So we have vacuum cleaners that are automated. We have automated suitcases, and we have which is just a voice command, right? Like using the signal processing and the audio processing. Now you can give a command to any electronic device, and you can make sure that you get the work done. So similarly, with the architecture that is available there, with the components that are available there, with the open source architecture, right? You can make sure that you can design and develop any system that you are in, that you can be utilized with, and that you have an idea in your mind, basically. It's a good when your company send a design to TSMC for fabrication. What if they steal your design and fabricate without your consent? I don't think that could be the case. Actually, that's a good question. I don't think that can be done. People do not give the entire design. They will give some layout level information. Actually, they do not give the hardware design information or such. Obviously, they will be they will be secured with, and make sure that TSMC can't steal the idea. And moreover, if the stealing is then, there will be IP infringement, and that will generally it won't happen. Actually, there are a lot of securities involved in it, and and again, it's the trust, right? And yeah, so security is obviously there with every design that you send to fabrication. Moreover, it's not the hardware design or such that you develop in the pre-silicon case. You give it in a encrypted format, in however the way the format is required. So yeah, I don't think that, but it's a good question. Yeah. Um, I do my suggestions on learning HLS over RTL, high level synthesis, right? So no, I did not work on HLS much. I might not be the right person to comment on the HLS actually. Yeah, you have any other question? If not, so yeah, please go through the PPT again. I think I try to accommodate as much as possible, and as low as possible. I do not include much of the technical terms to make sure that are being that are being addressed, to understand the concepts better, and you can choose basically what are the concepts that you are more suited with, and you can enter into the industry, in that particular opportunity actually. So make sure that you go through them. And yeah, if you have any additional questions, right, feel free to reach out to me. I have shared my mobile number. You can reach me through your LinkedIn. Yeah, and if you still need any other sessions required, right, feel free to reach out to me. I might be, I'll let you know my availability, and we can talk in our campus as well. Yeah. Yeah, my advice about VLSI, sir. Yeah. Before that, right, before answering that, so me and my thought, I studied standard books like Morris Monroe, yes, and DLD and DSD, and recently enrolled for the computer, yes. Am I in the right track? Yes, yes, obviously you're on the right track. Make sure, right, so you obviously you're on the starting path, that you have gone through all the standard books. Make sure that whatever the concepts that you learn in the standard books, right, make sure that you code them. You code them in Verilog or VHDL, and make sure you have a slight test bench developed around it, and understand how the signals inside those design is behaving, and are they behaving as per your requirement or not. So make sure that you get hands-on on them. So we have various tools that are available these days. You can use EDA Playground, and EDA is one of the open source platform that you can use. And make sure that you have hands-on in knowledge. For example, right, if you implement any combinational circuit, right, go and code it in Verilog, and simulate it in EDA, and you will observe, right, so whatever the combinations of input that you provide in, right, you get the proper output that you can observe in the in the waveforms there. So if you keep on increasing your complexity from the combinational circuits to the sequential circuits, and take out one FSM and then code accordingly, right, then you will get a very good hands-on, and you will be more comfortable with grasping the additional concepts as well. So yeah, you are on the right track. Make sure that you do hands-on coding on Verilog or VHDL. Make sure that you evaluate your results, and then accordingly, that would help a lot. Yeah. So we have open source from AMD. I don't remember the name exactly, but I think we have open source tools that are available. You can execute your projects also in that. EDA Playground is one such tool that that popped up to mind. But from AMD also there is one tool that you can refer. Maybe I'll check it out and let you know. Yes. Even the synthesis, right? That you can. I'll maybe I post the session. I'll leave it up to the comments. Yeah. Um, Finally, what is your advice to our students about VLSI? Yeah, VLSI is one of the area, right, which has huge potential, and it pays good. I mean, the work-life balance is good. You can explore, since we are mostly from ECE, right? So ECE, EEE, and CSE, they can explore, and the various opportunities that are available. Industries are really good, and the work-life balance is really good. It's up to, I mean, you can explore how much you want, and it's your enthusiasm that brings in, actually. So that matters. Your enthusiasm matters, and your learning matters, and sky's the limit for you. And people in the VLSI industry are also very accommodative. They are very helping with each other. It's not no hard limitations or such. I mean, uh, you will have a very good life in VLSI. At least I have a very good life in VLSI. Yeah, and there are a lot of opportunities, a lot of scope for improvement, a lot of scope for development. You can aspire as much as you want, and you can, if you are delivering right, or if you are learning, you are delivering right, and you are innovating right, then obviously you can reach any level that we talked about in the ladders, right? You can reach any level that you aspire for. So since I am in real estate industry, right? So obviously I recommend for the career, right? So with the number of experience growing, you will have good money, you will have good knowledge, and moreover you are more exposed to the problem statements in the industry, that you can be more innovative, and you can solve those problems. That really helps you and the world, actually. Thanks a lot, and yeah. So I would like to thank the fraternity, RGRRA, and I would like a special thanks to Rafi sir for asking me to present these slides. And yeah, yeah. Feel free to reach out to me again. Yeah, and thank you so much for the opportunity. Bye.